Hello aspirant, this question is from GATE 2019 Mechanical Engineering paper set 2, question number 6. Question is, consider a linear elastic rectangular thin sheet of metal subjected to uniform uniaxial tensile stress of 100 megapascal along the length direction. Assume plane stress conditions in the plane normal to the thickness. The Young's modulus E is equal to 200 megapascal and Poisson's ratio V is 0.3. These are given. The principal strains in the plane of the sheet are. So we have to find out the principal strains in the plane of the sheet. That is the strain in the direction of the axis that are falling in the plane of the sheet and not along the axis that is perpendicular to the plane of the sheet. To understand this better, we'll refer to the diagram. In this diagram, we can see the thin rectangular metal sheet. Its axis that is parallel to the length direction. I have marked it as x-axis, y being the axis perpendicular to the x-axis in the plane of the sheet, and z is the axis that is perpendicular to the plane of the sheet. Now in the question it is said that this sheet is subjected to uniform uniaxial tensile stress. So the uniaxial tensile stress is shown on the cross-sectional area and it is having a uniform value of 100 megapascal throughout the depth. We are being asked to find out the principal strains in the plane of the metal sheet. So, by generalized Hooke's law, the strain in x direction is equal to stress in x direction by the Young's modulus minus Poisson's ratio into stress in y direction by Young's modulus plus stress in z direction by Young's modulus. So this is indicating the effect of lateral strain while this is the longitudinal strain. In this particular case, as we have only a uniaxial uniform tensile stress, the stress that is given, sigma x, is nothing but the principal stress, sigma 1. So in accordance with that, if we write the equation for principal strain in the metal sheet, we have epsilon 1 is equal to sigma 1 by E minus V into the other two principal stresses, sigma 2 by E plus sigma 3 by E. Epsilon 2 in perpendicular direction to epsilon 1, we have sigma 2 by E minus V into sigma 1 by E plus sigma 3 by E. So when we consider the y direction, the lateral direction is along x and z. That is why we have written sigma 1 by E plus sigma 3 by E. This is true only in this particular question because sigma 1 is along x direction. Let's substitute the values that are given is equal to sigma 1 is 100 upon Young's modulus is given as 200. The units are matching, both are in megapascals. So we'll write as it is minus 0.3 Poisson's ratio into sigma 2 and sigma 3 both are 0. So this bracket will turn out to be 0. Hence we have the value to be 1 by 2, that is 0.5. Let's compute the second one, that is epsilon 2 is equal to sigma 2 is 0. So it is 0 minus 0.3 into 100 divided by 200, the Young's modulus. This is equal to 0.3 into 0.5, that is minus 0.15. So the strains in the plane of rectangular metal sheet in the x direction or in the first principal direction, it is 0.5 and epsilon 2 is minus 0.15. Let's look for the option that is correct. Yeah, the correct option is C. To learn more about analysis of strain, you can refer to the NPTEL video Analysis of Strain 5 lecture series on strength of materials by Professor S.K. Bhattacharya of Department of Civil Engineering, IIT Kharagpur. I hope you understood the solution. Thank you.